Welcome students. Today we are going to see about basic proportionality theorem, BPT in short, or Thales theorem. Okay, so let us start with the statement. Always relate the statement with a picture. Okay, so in a triangle, so let us draw a triangle and name it as ABC. The line drawn, so let us draw a line. With what condition? We just drew a line. With what condition? Let us see that. Parallel to one side. So this line drawn is parallel to the side BC. Next what? Intersecting the other two sides. The line which we drew parallel to BC is intersecting the other two sides. That is namely AB and AC. So AB it intersects at M and AC it intersects at N. So I'll sum it up. In a triangle, the line drawn parallel to one side, that is BC, and intersecting the other two sides, that is AB and AC. What happens next? Divides them in the same ratio. So let me explain. Now what the line MN divides the side AB into two pieces, that is AM and MB, and it divides and it creates a ratio. What is that ratio? AM by MB or BM. So this is one ratio which is created, and the same line MN divides AC into two line segments, that is AN and NC or CN. So that becomes the second ratio, that is AN by CN. So this is another ratio. So these two ratios are equal. That is what the theorem says, and we have to prove that. So let us start with the proof. So the statement is, in a triangle, the line drawn parallel to one side intersecting the other two sides divides them in the same ratio. So what is given according to the statement? So in triangle ABC, M and N are points on the sides AB and AC respectively. Okay, so we have a triangle and we have two sides, two intersecting points which we take it as M and N. That is, on AB it is M and AC it is N. So what shall we do? We take that points in such a way that MN is parallel to BC. So we draw M and N, we draw the line segment MN in such a way that it is parallel to BC. So these are the construction which we do and the given information there. Okay, so next what? To prove, what should I prove? As we discussed earlier, these are the two line segments, four line segments, and we create two ratios with that. So those ratios are equal, that is AM by MB is equal to AN by NC. Okay, now what is the proof? Let us get into the proof. In triangle AMN, so that is the small triangle which is AMN, and we take it separately and keep it aside. Okay, so for better understanding, we draw this triangle separately there. And the original triangle, that is triangle ABC, we take that and keep it aside as well. Okay, so now you have two triangles because of this line segment MN. What happens? You have two triangles, that is AMN, and the next triangle is ABC. So what is happening in these two triangles? You have angle A which is common, which is the same angle. Okay, so those two angles are equal. Angle A is common. Next one is angle B in the big triangle. Angle B in the big triangle and angle M in the small triangles are equal. So what is the condition for that? I've mentioned in the main picture as well. That is, those two are corresponding angles. If you have two parallel lines, that is MN and BC there, and if you have a transversal, that is AMB is a transversal, we get two corresponding angles, that is angle M and angle B. So those two angles are equal based on that transversal and parallel line concept. So you have in these two triangles, you have angle A is common to angle A, and angle M is equal to angle B, corresponding angles. So based on AA similarity rule, we can confirm that triangle AMN is similar to triangle ABC. So once the similarity is proved, we can take the result from the similarity. So that is AM by MB. AM by MB is equal to AC by AN. Okay, so this is from similarity. Next, AB is split up into two pieces. AB is the sum of AM plus MB. Similarly, AC is split up into two terms, that is AN plus NC. Now we distribute the denominator to both the numerators, that is AM by AM plus MB by AM equals AN by AN plus NC by AN. So since you have the numerator and the denominator same, it becomes 1 in both left and right hand side. So 1 plus MB by AM equals 1 plus NC by AN. Now both the side or the 1 gets cancelled. Now you have MB by AM is equal to NC by AN. So that is the proof we are looking for, but in the inverse form. So let us inverse reciprocate both the sides. So it becomes AM by MB equals AN by NC. So and that proves the theorem. So from this theorem, you can also confirm two corollaries. So from the original theorem, we have AM by MB is equal to AN by NC, and the corollaries, two corollaries, one of them is if MN is parallel to BC, then we can also confirm that AB by AM, that is the full segment with the first part, is equal to AC by AN. This is one corollary. Second one is AB by BM, that is the second part, full part with the second part. AB by BM equals AC by CN. So these are the two corollaries. So if MN is parallel to NC, that is if one side is parallel, if the line drawn is parallel to one side, then we can have three set of ratios which are equal, and those are the three results which we have from Thales theorem, which is an important theorem, and hope you understood well and do well in this theorem. Thank you.